The next topic that we have is dynamic memory allocation and deallocation, the freeing the memory. So what exactly we do is whenever we need a certain amount of memory, like for arrays, let's create a simple array and we will allocate, for example, I say I have an array. Remember, we are going to use this asterisk for creating an array. And this array is supposed to, for example, hold like 5 items or maybe 10 items or whatever. So we'll have to tell the system to allocate that size of memory, size of the integer, multiplied by 5, that number of bytes we need to allocate. So we'll say memory allocate, malloc, M-A-L-L-O-C, memory allocate. And in here, we'll have to pass the number of bytes that we need to allocate, okay? So we say size of integer, whatever the size of integer is in the target compiler that we're compiling it, multiplied by 5. So we'll have 5 different locations allocated. This 5 integers would be allocated here. Now the thing is, whenever you allocate, you should be casting it back. Some compilers won't complain about it, but you should be casting it back to whatever the type of your source array is. When you're creating an integer array, pointed to an integer, so this should be pointed to an integer. So this is allocated. Now what you can do is you can treat this array that you have allocated in the memory at runtime. Otherwise, how would you do that? Otherwise, you would define it like this, and that's it, you're done. But this is static allocation, and we are not studying this. We are studying dynamic allocation. We allocate at runtime, and then we simply use it here, and then at the end, we free the memory. Whatever we allocated, whatever amount of the memory that we have allocated, we would definitely have to free it. In upcoming lectures, we are going to study some functions that we can register that will execute at the end of the program automatically and free our memory whatsoever we have allocated. Okay, so now back to the topic. We are studying array, and array is dynamically allocated. We can simply assign, for example, we say the second element, value of the second element is 100. So fine enough, it's just being treated as exactly as we create an array and treat it. And we will say, okay, print the value of the third element. For this is the third element of the second. 2 means the third element, 0-based index. And we will just compile it and run the program. We see the value that has been assigned to this part has been returned and printed. So I hope you do understand what the dynamic allocation is. We're going to use this function, memory alloc. There are some other functions which are reallocate and CALLOC. These are the functions that we will look into. In the meanwhile, reach it. I hope you just go and check it somewhere. On the web, you will find a definition. The most used function that in the C source code would be malloc, M-A-L-L-O-C, memory allocate. And here, just remember this most important part of this lecture is the malloc function actually allocates in terms of bytes, not in terms of the number of values that you require. So what we did is we got the size of integer and we multiplied it by 5. That is our number of elements. This is our number of elements. The 5 is number of elements that we require, and multiplied by the size of the integer. That will allocate and indicate to the function exact number of bytes that we require for this pointer that we are treating as an array. At the end, it's really necessary you remember and you don't forget to free the memory that you have allocated.